Good morning, everybody. And it's gonna be a discussion for week 2 lecture. I did see some questions on Google Doc. I just checked it about 30 minutes before the session started. So I'm gonna go over them first, but before that, I would like to talk about some announcement, as usual, just to make sure everybody is keeping up to speed with the course. Okay, you may also got some questions related to what's gonna happen after February 14th. I will address that as well together. Right, so the announcement, quite a bit today. Well, many things are happening here. Number one is about lecture week number 3 has been released. Okay, so week number 3 is when we actually start applying the math that we review in the first 2 weeks into some application domain. Specifically, we'll talk about reactive system. And for the first case study, it's going to be a bridge controller, which we're going to spend very likely maybe up to maybe 4 weeks to talk about the entire example developments, because it's going to involve just not a single initial model, but also we're going to talk about 3 subsequent refinements, and we're going to explain every detail, hopefully as perfectly as possible. Right? So stay tuned for all the subsequent lectures about this particular case study, and then after reading week, we're gonna start with other application domains. So that'll be the plan, right? Just make sure you study that week number 3. As just make sure you get started in time. And your lab number 1 solution has been released yesterday, right? In case you're wondering about where to find them, go to your e-class page, and then you will see under your lab exercises over here. Again, no submission will be required for your lab. But the expected completion date for your lab number 1 will be this Friday, which will be tomorrow. And today, if time permitted, I'll try to maybe highlight certain parts in the lab 1 solution that you want to pay attention to. You can go over them over the weekend. If you got any questions, well, actually not even over the weekend. If you got any questions about the solution, you can either drop by my office hour today, 2 p.m., or you can drop by my office hour either maybe Monday. And Tuesday will be your written test 1, right? I'll talk about it as well. And that'll be the solution, which contains a PDF version of the machine and the context, including the solution to all the exercises, and also the rodent project. You can simply import it. Look at the readme.txt file. It talks about how you can import the solution project. Right? I'm going to rely on you to really go over that, but any questions, reach out to me, and then we'll clarify. But I'll try to highlight some important aspects you should really pay attention to today as well. All right, so that's about lab 1 solution. And then we also got some example question for your written test number 1, right? Over here. Before I go on to the example question, let me just remind you about written test number 1. I already released the guidance about the coverage and policy, etc., right? It's already released last week. So look at the guide if you haven't. That one outlines the policy that you have to obey for the test. Right, look at the guide, and then if you got any clarification needed, you can ask me now, maybe later. Okay, I'll open the floor in a moment. Written test 1, and then if you look at the calendar right now, we are here today on the 27th. So your written test number 1 will be during the scheduled class time. So it'll be Tuesday, February 1st, 11:30 a.m. sharp. Right? If you start later than 11:30, that means you got less than 30 minutes to complete your test, right? That's said clearly in the guide. So please make sure you read the guide and make sure you're clear about the policy, right? You got 30 minutes to complete your written test number 1. If you want to see some example questions about the formats or what kind of question might be some question that you can expect in the test, you can go on to the e-class over here under written test. We got example questions for written test number 1, right? But I mentioned over there in the written test, number 1, it doesn't really cover all the topics that you will be assessed, right? It's not meant to be complete. And also number 2, you definitely want to get familiar with the formats and the flow of the test to make sure you wouldn't maybe start late or have any hesitation about submission or etc., right? You can definitely practice that. Number 3, the questions I posted over here tend to be more on the easier side, meaning that you should still study everything that you're supposed to study. That's laid out in the preparation guide. All right, that's something I want to remind you. Just make sure you don't really miss any items when you study. All right, before I go on to the in-person learning beyond February 14th, for what I have just said so far, do you guys got any questions? You can feel free to ask now before I move on to the next item. Anyone? Anybody? So I hope things are clear so far about what you can expect, right? So definitely you want to get prepared for written test number 1 next Tuesday, right? And I don't think we will actually get a chance to really go over the example questions, but I think they're rather clear because I think for some question there, I even put some feedback just about how you can understand the solution. So you can also look at them. But I still got office hour either this afternoon at 2 p.m. or Monday 2 p.m. You can definitely drop by if you want to discuss any of the questions. Or simply write me an email. I can also try to respond quickly if I can. All right, one more chance. Do you guys got any questions related to these items before I move on to the return to in-person plan? All right, hearing none, seeing none. Let me now talk about the tentative plan, right? I will hopefully by the end of next week. Of course, I definitely have to confirm the plan by February 14th, but I'm hoping to confirm with you if earlier if I can, right? But hopefully by the end of next week, I can confirm with you in writing. I'll definitely make sure it's an official e-class announcement to confirm all the details. But I think more or less it's going to be as follows, okay? Which is very consistent with the email, the announcement I communicated with you last Friday, right? Remember, you guys did a survey. Many of you actually participated. Thank you. And not really everybody was able to participate, but that's okay. I can definitely see the trend about the preference by the class. I think what's going to be unchanged about the course would be for your weekly lectures. I will still actually do the pre-recordings, so you definitely don't have to worry about coming to some live lecture. Like before the pandemic. I think that will give us some flexibility, and also that can also ensure the quality of the lecture, so we don't have to rush for you guys to pack up to the next lecture, right? That's something what you have to do if you do in-person lecture. But anyway, at least for this term, maybe next year when I teach 3342 again, maybe I have to stick to more like an in-person. But at least for the remaining of the semester, let's be consistent. You can definitely expect to receive my weekly lecture recordings on Wednesday on my YouTube channel. Right, I'll maintain that consistency. And as for your weekly Q&A and also for your office hour, okay, so notice my wording over here. I said it's going to be Zoom in the first instance, meaning that we're still going to keep them online, at least for now. If I maybe towards a little bit closer to the end of the semester, maybe I found that maybe you guys really would like to maybe see me in person, maybe have some in-person interaction, I can definitely consider maybe having maybe 1 or 2 hours in the week, maybe to actually have some in-person activity. But even if I do that, I will still record the session, except for the office hour, I mean the Q&A, right? But at least there will be Zoom for now. If I really want to adapt some of them to be in person, I'll let you know explicitly. Okay. And about your weekly schedule labs, and also they will be Zoom also in the first instance. I think one of your TAs, they said they actually have no preference as to offering the lab either in person or over Zoom. I'll confirm with them maybe once more soon. Maybe they changed their mind. I don't know. But I think at least you can definitely get attention of the TA over the Zoom for sure. We'll get the attention from me because we use the schedule lab. It's more like a Q&A. We don't really need to actually do anything that's required. All right. Okay, so that's about the schedule lab. And for the most important thing, of course, is about your single programming test or your 4 written tests. For your written test number 1 is confirmed. It's going to be online, right? I already released the preparation guide a week ago, so that one wouldn't change. For your written test number 1, for sure it's going to be online. So written test number 1, it will be online, for sure. Okay, and for your written test number 2 to number 4, and also for your programming test, they will happen after the reading week, right? They're scheduled to happen. Again, I would say in the first instance, they will be online. However, officially, since we already returned back to campus, it would be possible if I decide for some of them when I release the preparation guide for some of them, maybe usually it will be at least 1 week beforehand. When I release the preparation guide for each one of them, I will confirm about the formats for the test. I might say, guys, please, for this particular written test, come back to campus, and then we're gonna take it in person. But you will get at least 1 week notice so that you can get prepared. But in principle, they will be online in the first instance. But I might change that, right? So that's some flexibility I would like you guys to note, right? Which I put here. And what's really confirmed is for your exam is going to be in person. There's no nothing I can change for that one. I think I already submitted our request for like a exam, and the department said it has to be in person, and it's going to take place sometime between during the exam period, which will be in April. So your responsibility is don't make any travel commitments or make any other commitment which will make you unavailable for the in-person exam. Either it will take place in the exam center or maybe take place in some lecture hall. I don't know. We gotta wait for the registrar office confirmation. All right. So for this one here, I will not be able to accommodate if you say you are simply not in the city or you simply cannot make it to the exam for any non-medical reason, right? In that case, there's no accommodation available. If for those of you who actually went to the virtual town hall last Friday, I remember one of the questions was, what if the students, what if they cannot actually come back in time for the in-person learning? So the university's position was either you have to switch your enrollment to some remote section if that's available, but that's not the case for this. We only got one section, which is in person, or you got to drop, right? That's the university's position, not mine, right? I'm just the messenger, okay? All right, so that's about the tentative plan, right? So the only thing that will remain flexible is about your written test 2 to 4 and also programming test. In principle, they will be online, but if I may just change change some of them to be in person, but I'll definitely let you know at least 1 week in advance. That'll be the message I would like to talk to you today. Any questions related to this plan? Anybody? You can feel free to ask right now before we get on to the technical contents. I'll pause longer in case you are thinking, you're phrasing your questions. So everybody's clear about how we're going to move on for the course? We're just about 1/4 finished for the course, just about. All right, so I can assume everybody's clear about the plan. All right, so seeing none, hearing none. All right, let me move on. Let's now first talk about the Google Doc question, right? So I got 1, 2, 3, and 4. We got 4 questions over there, but feel free to bring any follow-up if you want to, right? Let's go one by one, okay? The first one here is just for clarification, right? So I think this is the notes I wrote in the week number 2 lecture when I try to explain about the algebraic law of the relational overriding, right? There's a relational overriding operator. And by the way, for your written test 1, as I clearly lay out in the guide, you're supposed to know the ASCII characters for all the mathematical construct that we spoke about in the first 2 weeks, right? I already gave you many examples in the guide. So you're responsible for looking up others and make sure you can feel free to prepare data sheets for yourself so you can also look it up during the test. That'll be okay, right? All right, for this one here, I think your fellow student question was, would it be okay for me to write instead of just T? You can see by definition, we say over here, R overridden with T is simply T itself union with the domain subtraction of R, right? That's what we're doing. And it's really important to see why we are writing this. So you can think about the T over here is basically a relation, which will be simply a set of pairs. Similarly, if you try to look at this expression over here, which will be the relation domain subtracted by another set of values, the result would also be a set of pairs, just another relation. So this is why we can use the union operator over here, which is supposed to try to combine two compatible sets together. The question was, can I actually write this expression over here, specifically this part over here? Can I just say T is a member of R, right? So hopefully you can see the way I'm getting to. This would not be allowed. It's simply not type correct because the union operator is expecting a set, yes, but this is not a set. This is only a proposition, like a Boolean expression. You cannot really union a Boolean expression with another set expression. It's simply not allowed, right? It's not even valid. So the question, so the answer to your fellow student is no. It is not type correct. Right, writing type correct expression is very important for your written test number 1. Actually, also for later tests and exam. So I think starting from written test 1, we'll be strict about what you have to submit as answer. So you can definitely see some ideas in your example questions. Okay. Right, do you guys got any follow-up to this? Anyone? Anything that's not clear to you, you can feel free to bring it up. Anybody? Okay, seems like everybody's okay. Yeah. Okay. All right, let's now move on. Right, I'll take silence as okay. All right, let's now move on. And this question here from the Google Doc. If I want to prove that a function is not bijective, right, meaning that you want to disprove it, not bijective, meaning that you want to disprove it, right? All right. Can I simply prove that it is not total, injective, or surjective, meaning that you're only going to disprove one of them? Suppose it is not total, do I still need to check that if it is still injective or surjective, right? So there are two parts of the question, right? So number one, can I simply show that it is not total, not injective, or not surjective? Yes, you can just prove one of them. The reason is we say that if a function or relation is if a function is bijective, if a function f is bijective, by definition, that means f is actually is total, right? You know what the definition is for is total, so I'm gonna leave you to that. And is injective and also surjective. But you can see from the definition here, it's simply conjunction over here, meaning that if you want to disprove it, you want to make this false, you can either prove that this is false, that'll be enough. You don't need to prove anything else. Or you can show that this is actually false, that'll be also enough. Or you want to show that this is false. If you actually go back to the example we did at the end of lecture week number 2, you will see that that's exactly what I did, right? I kind of concluded that since, for example, a function is not injective, in that case, it cannot be bijective because it's going to be all the 3 criteria being satisfied all at one go. You cannot say you only satisfy these 2, but not this, and still be a bijective function. It's not possible. Right? So for the first one, yes, you will be okay. And for the second part, if it is not total, do I still have to check if it is injective or surjective? If your goal is really to disprove that it is bijection, in that case, no, you don't need to go any further. Okay. No, it suffices to disprove that f is bijective by showing that it is not total. Right, so that's the answer. Okay, it would be sufficient to disprove that it is bijective by showing that it's not total. Right, or of course the similar argument apply. It'll be sufficient if you only show that it's not injective, or it'll be sufficient if you only show that it's not surjective. That will also be fine. All right, it's a quick clarification. Any follow-up to this?
Could I ask a follow-up quick?
Please go ahead.
Okay. So when it comes to disproving things
Yes.
in this course,
Yeah.
there's many techniques we can use to disprove a
Mm-hmm.
statement, right?
Right.
We can assume it's true and arrive at a contradiction,
Yes.
or we can simply provide a counterexample.
Yes.
In terms of disproving statements about functions,
Mm-hmm.
in your experience, what is the more consistent approach to disproving
Yeah.
something?
Good.
Like, would you rather reach a contradiction or maybe just provide a counterexample?
The latter. I think specifically, if you want to disprove that a function has certain property, disproving some function holding some property p, right? Let's say that's a problem you're talking about. Let's say function specifically. I cannot say for general case for anything else. That would not be practical. If you just want to disprove that a function holding certain property p, I would say the most consistent way you can do, and also I would say the easiest way to really do, is by give a witness such that not p is the case. That'll be the counterexample. Yes.
Okay, I
However,
see.
yeah. However, let's say I'll be fair. If there's really some question which you guys really haven't seen so far in the course, for example, you didn't see that in the lab, you didn't see that in the lecture, you didn't see that in the Q&A, that'd be the first time you have to use this. Let's say what you said, for example, proof by contradiction. I will give you some explicit hints in the question itself. I would say for this question here, you may not want to prove by giving like a counter example. You may want to prove by contradiction, something like that. I'll let you know. Yeah. But otherwise, I would say
Okay.
it will be a safer bet to simply go for a counterexample. That'll be the easiest one. That's basically what
And
we have been doing so far. Yeah.
so in the case of a function, maybe as an example, if we wanted to prove or disprove that a given function is one-to-one,
Mm-hmm.
right?
Yeah.
Um, what
Similar.
it would be enough to say like let's take 2 points as a witness or
Mm-hmm.
two I guess pairs as a
Oh, I see.
witness,
Yeah.
and then
So
you would say you would go about and
yeah, let me
do it
give you
that
one
way, right?
example. Yeah, similar is
Yeah.
most similar to this. I would say, let's say you're given a function, and then let's say prove or disprove. It is bijective. And let's talk about this function here. Let me just give you a concrete example here. Okay, so let's say this function here, let's say f is simply, let me just say s and t, so that's important. Let's say s will just be abc for set, and t would just be 1, 2, 3. Just make it easy enough. Let's say the function f we are talking about, let's say it is, let's say a1, b2, and also c1. All right, let's say this. Okay, and the question is prove or disprove that f is bijective. And it's indeed similar to the exercises we did in lecture number 2 at the end. You can also refer to them for more example. But let's talk about this one specifically, right? Prove or disapprove. And if you want to prove it, in that case, you want to show it is total, it is injective, it is surjective. That's what you want to prove. If you want to prove that the conjunction is actually true, you want to show that every conjunct over here is actually true. That's what you got to show. If you want to disprove it, all you got to do is choose any one of them. That'll be sufficient to show that. If you can show that either one of them is actually false, in that case, it will be sufficient to conclude it is not bijective. What about in this case? Can you tell me? Can you choose any one of them to show that it's false?
Sure. I think I see all of them. Let's pick the surjective, right? There
Ah,
exists
subject.
some
Yeah.
yeah, there exists some
Indeed.
element in
Exactly.
T such that there's no mapping to it. So we'll take 3. There's nothing that maps
Yeah.
an element from S
Yeah.
to 3.
Exactly. Exactly. So that would be one. I actually that's good. So there are two possible ways you can show that, right? So approach number one. I'll say approach number one. You can say it is not subjective, as you said. I agree. Because if you look at the range over here, it's going to be 1, 2, and also 1. 1 and 2, which is not exactly equal to the t. So that's not subjective. Or approach number 2, you can actually say that it's actually not injective, because you can see here we got 1 and also 1 over here, right? You can see A and C being distinct domain values mapped to the same range value. So that means it's not injective. Okay. However, it is total. A, B, and C, indeed, right? So it is total, but it's not injective. It's not surjective, right? Okay, I hope that answers your original question about how to prove bijection. Jora, go ahead.
So if we're trying to prove that it is total, is it sufficient to say that the range of F is equal to S, and then therefore it is total?
Nope, you meant to say domain.
Domain, sorry.
Domain, yes, you're right.
Okay,
that's
gotcha,
very good.
Gotcha.
Very good. Yeah,
Okay.
If you want to prove that it is total, either prove or disprove, you're going to argue about what's the current domain for the function. If that's exactly
Okay.
equal to the first set, then that's good. Otherwise, it should be a counterexample. Yes.
Okay, thank you.
Very good. Yeah. Yeah, guys, please be careful when you write a test, since many parts of the question, as you will see in the example question, will be graded automatically. So that means you really want to be careful with the typing. Okay, just be careful, right? So hopefully you can practice as many times as you like for the examples. And Patrick.
Yeah. So on
Yes.
the topic of the automatic grading, right?
Yes.
I was doing the practice test and I noticed that I guess the automatic grading wasn't really to the student's advantage at all, right? Like you would make one tiny typo and it would be entirely wrong. And I understand that it's like that for a reason, but I was wondering if we do in-person tests, will we be graded on syntax more or on semantics? Like if the question is testing us on our understanding of the situation.
Yeah, I
Even though
can.
syntactical error.
Yeah.
I hope you get what I'm saying a little bit.
I definitely get what you're saying, but inherently, having tests online versus in person, they cannot be the same, cannot be tested the same way. I think for in person, well, depends on how I instruct the TA. I might even tell the TA to say, well, since this is a math question, right? Is the answer is gonna be correct, like a one-line answer. If a student makes some mistake, maybe we can only give some very tiny partial mark, but you got to be exactly correct in order to get a full marks. That's how I would instruct the TA, even if we're doing that in person, maybe the exam. So I would say I would try to not really make the majority of the question in your online test to be more like a filling in the blank, and then it's going to be 100% correct, maybe some percentage, but not to be the majority. So other question might be more like a multiple choice, so you can really choose from the different answer. I think the reason I want to really have this kind of like a fill in the blank question is I want the question to be precisely correct. So when you say you make some tiny mistake, I think even if you just missing a parenthesis, so that means you really got to double check your answer to make sure. Let's say this, right? Let me say this. So one of the question was about the existential quantification conversion. So if I got something like, let's say for all x, I'll put a slightly easier one. Let's say x is a member of integer. It is the case that x is larger than 0, for example, right? So if you want to put this back to into another existential quantification, in that case, you want to make sure you actually put the existential, but you're going to put a not over here and make sure you put a parenthesis that actually matches, right? If you don't really have to match, so that means it's not exactly correct, right? So in this way, you're right. You wouldn't get any partial mark if you got it wrong. So that's why I said you got to be careful when you actually do this kind of question. But as I said, I wouldn't make this kind of question as the majority of the marks. Maybe it will occupy, maybe I cannot say the percentage, but I will there will be many different type of question in your test, right? So
I noticed it with the rodent syntax, right? Like we can express a product in a couple ways, right? So if I was to write maybe X and then put the asterisk instead of a period given context,
No, if you talk about cross product, I believe there's only
No,
one.
not cross product, not cross product. I mean multiplication of two values, x times y.
Mm-hmm.
So yeah, like this, but isn't it also possible to just use the period?
I'm not too sure if that's true. I can look it up. I think that should be how you actually do the multiplication. I can look up the summary. But if that's the case, don't worry. If that's the case, if there's more than one way to write the expression, if you wrote it properly, if somehow my answer didn't really accommodate it, you can come back to me, and then I can definitely give you the marks. Right? It's a different scenario than simply making typos or making mistake on the answer. Right?
Mm.
So my point is, if you're asked to submit an answer over there, if you simply submit it in a way that's actually also valid, but somehow my answer, my model answer didn't consider, I'll be willing to consider for sure. That's for sure. But on the other hand, if you just submit a wrong answer with some typos, with some mistake, spelling mistake, in that case, no, that's not it. Something I can accommodate. So I hope that answers your question. I hope. All right. Do I? Okay, got another question here. I think it's Chidalu.
Okay. Yeah, I had a quick question on the last slide you're just on.
Yeah.
Can you go back to it?
Yes.
Yeah. If we wanted to prove that this function was injective, would we have to go over every possible pair of points and show that no two different points have the same? I guess
that's correct. You have to go, yeah. So you can definitely look at the universal quantification we did for its definition. If you want to show that this function here, for example, is injective, you basically want to say for all the instances where the range values are actually the same, you want to say that the domain values should be the same as well. Well, cannot be the same, basically. In this case, it is not, because you can see the two range value being the same. In that case, A and C are not the same. In that case, it's a violation.
But like, you can never have like, because this is a set, right? So you can never have like duplicate like in the set.
No, not really. I think any input set I will give to you, there will not be any duplicates for sure. So you can see here we got no duplicates, right? So I wouldn't give you a set, for example, to say A1 and A1 repeating itself twice. It's not valid. You cannot conceptually don't have any duplicates in the set.
Yeah, that makes sense.
Awesome. All right. All right, so guys, I think I'm glad you raised up the question about, let me go roll back, about the written question about filling the blank, right? It sounds harsh, I understand, but that's why I also gave you some very concrete example questions so that you will know how to get prepared. Just be careful when you answer that kind of question, right? That's what I can say for now. All right, any more follow-up to this question specifically, please? Feel free. Okay. Oh, just came to my mind. That will save you some lookup as well. Guys, how do you write empty set as ASCII key? How about that's a pop quiz? Can you type on the chat? How do you write empty set? ASCII character. Okay. I can see the correct answer from Alice. Very good. All right, that's how you do empty set. So maybe your answer is supposed to be empty set, right? So that should be exactly right. Okay, let's now move on. Okay, that's another question on the Google Doc. Okay, so I kind of rephrased the question slightly, just make it a little bit more concise. Okay, but that's definitely capture the essence of your fellow students' question. How can we enumerate this set over here? And what is this set precisely? It will be the set of partial functions between 1, 2, 3 and AB, basically, right? Or you can think in this way. The strategy I would suggest, I'm going to do partially, and you can definitely complete. Okay, I'll show you how I would do it. Okay, you can think about the diagram over here. I think maybe we also drew such diagram in the lecture. I don't quite remember. Maybe we did. Okay, first of all, think about how you can enumerate just the relation. You know how to enumerate the relation completely. We spoke about it, right? So I would say, first of all, you try to go on to enumerate all the 1, 2, 3. Let me just write it properly. So 1, 2, 3. 1, 2, 3. And then relation, right? That's a relation symbol. And then AB. Okay, enumerate all the relations first. And then while you're doing that, whenever you see any member relation that does not satisfy the functional property, that means they should be discarded from the result because they are simply not partial function, right? So there will be a strict subset over here, right? You can see this is a strict subset over here. And this subset over here would be the 1, 2, 3, and partial function AB. Right? And what does it really mean? When we have a member over here, that is actually a relation, but not a partial function. What does it really mean? It simply means, over here, it is a relation, but violating the functional property, right? And informally speaking, the functional property really is you cannot have the same domain value that maps to more than one range values, right? That's the definition. You can definitely look it up in your slide, all right? So the way I would do this question over here would be, I will simply just try to construct the blue set over here about the set of all relations in this set over here. And then every time I'm done with a particular relation, I'll check it right away to see if that should be also a member of a partial function. If it is, I'll keep it. If no, I'll simply cross it out. That's how I would do it. Okay, let me show you. And remember the systematic way that we spoke about in the lecture, right? I will just give you a little bit example over here, just give you some feel, and then you can definitely refer to the detail back to the lecture, right? Let's now do that. What I want to do is I'm going to have a set over here, right? Eventually, okay. And the way, what will be the, so let's talk about relation first. What will be the minimum relation between this and this, right? Empty set. That one is obvious, right? And now the question is this empty relation at the same time a partial function? Yes or no?
I think vacuously, yes.
Okay, good. Yes, I agree. Trivially, that's how I would put it. Because if you think about applying the universal quantification about the functional property, you just cannot find any witness for violation. So that's why this is automatically is a partial function. All right? Yeah, very good. Right, so this is good. I'll say check. I want to keep that. So this indeed is both a relation and also a partial function, right? So that should be kept over here, right? So that's why I put a check. Let me go further over here. And the next one we should really enumerate will be all the relation of cardinality 1, right? So we want to go for cardinality 1, cardinality 2, all the way to cardinality that correspond to the maximum relation between these two sets. And we know very well the maximum relation is going to be basically just 1, 2, 3 cross products AB. So that'll be cardinality 6, right? 3 times 2. And let's talk about this one specifically. Is this a function? Let's say your goal right now, prove or disapprove this relation here being a function. Can you prove it or you want to disprove it? Anybody?
I disprove it.
How would you disprove it?
I would say that it's not. I would say that it's not injective.
Oh, I think you're overcomplicating the stuff. Since we're only talking about being function or not, you don't even need to worry. You know, even if it's not injective, it doesn't really mean it's not a function. You gotta be careful,
I guess I was confused about whether or not in this course we would say that we only define bijective as being functions. You know how in some I think I was getting a little confused.
I'm not sure if that's really the case for other courses. Okay, let's make it clear over here. Let me draw a diagram for everybody's interest. Okay, I'll come back to here in a moment, right? I want to make sure there's no confusion. I'll be surprised if other courses will teach otherwise. But let's now see, all right? So the biggest set we are talking about is the relation, right? That's the biggest one. Okay, as big as I can get to. That will be S relation T. That will be the most general set, meaning that we want to get a set of pairs between two sets, S and T. And then there is a strict subset over there. Over here, okay, this guy over here, that's actually something called partial function. And the only thing you want to make sure is for those relations that satisfy the functional property, that will be a partial function. Meaning that every function is a partial function. Actually, that's one of the questions on the Google Doc. So I just answered that, right? I'll revisit that. Every function we are talking about, either we're talking about injective function, surjective function, bijection, or even a function that's injective but not surjective. But as long as it's a function, you can always say it's a partial function. Okay, there's a set over here. Now, within the confinements of this set, what we got is, let me talk about the next one. There is a category of function over here. It's called the total function. Right, so this one here, because this is actually a subset of partial function, so that means it must satisfy the functional property for sure. But what's the additional property we wanted to satisfy? Anybody? Pop quiz. What's the additional property we want this category of function to satisfy in addition to functional property?
The domain of the function has to be equal to S.
Absolutely. Thank you. Absolutely. The domain of the function, right? Assuming that function is being declared somewhere, is equal to S. Very good. All right. Hopefully, so far it's clear about the hierarchy between relation, partial function, and also total function, right? So that means if I got a total function over here, let's say this member over here, it would be the most accurate for me to say this is actually a total function. However, it's not wrong if I say this is a partial function because it's still a member of this set over here. It's also not wrong for me to say it's a relation. Guys, can I give you some analogy? I think you guys took maybe 2011 in the not so distant past, right? Sometime earlier, right? Remember when we said if you got an input function here, let's say f of n is simply 2n squared plus 3n plus 4, right? I'm pretty sure you know, if I ask you what's the asymptotic upper bounds for this function, you would say it's big O of n squared. Agree? It's the most accurate way to say that. However, it will not be wrong if I say it's also big O of n cubed. It's also big O of n 4. And also it's a big O of 2 to the power of n. It's also not wrong. It's just not accurate. So similar analogy over here, I can say this function over here being total, definitely the most accurate to say that would be it's a total function. Implicitly, I'm telling you not only that it's total, also it's partial, it's also relation. But it will not be so accurate if you only say that it's a relation because you're missing many properties that this function also satisfies. All right, hopefully that's clear for everybody. All right, and then let me say one more. And as you just said about the bijection, right? Bijection is really something that's actually here. Bijection function must be total, right? S. I think something like that. I forgot. Okay, I gotta look at my data sheets, right? So that's a bijection. Guys, can I just look up the slides quickly, just to make sure I got it right? Okay, of course, please make sure you got your symbol right when you write a test, but let me be precise. Otherwise, I'll give you the wrong information. Let me just take a look. All right, bijection should be, there we go, over here. Right, it's always total. Okay, so I think what I got wrong was there. Give me a moment. I'll fix it. Okay, let me just go back over here. Right, it's injective over here. So this tau over here, remember that's about injective. And also this double head over here is about surjective, so it's a bijection. And when we talk about a bijection over here, if it is a member over here, right? So in this case, it's going to say that this function here is a bijection. That's the most accurate of saying that. It's also at the same time total. It's also at the same time partial. It's also at the same time a relation, right? You can see the hierarchy over here, right? Of course, you can also try to introduce other concepts. I'll just give you one example for the injection, right? Let me use another color over here. There's another category over here. I think that should be the right way to draw that over here. Yeah, you know what? Let me just draw better. I think that would be the way to do. Okay. So this one is really about injection. Okay, so what we are saying that injection itself can be partial, right? Injection itself can also be total. And there will be some specific set of injection that's also bijection, given that it's also surjective, right? I didn't really draw the circle for surjection, but you will see. And Jora, I can see you put a symbol for us on for the bijection. Thank you on the chat. All right. Hopefully this diagram also help you kind of understand the different functions. You can feel free to put other functions into context, right? All right, so that's about, okay, that's kind of like a digression, right? Patrick, you got some question.
It's kind of like a follow-up to like
please
the previous slide, like
here?
where we were talking about the Cartesian product. Yeah,
yes,
like
yes.
We're back here now.
Yes.
The reason I was kind of confused, like when you said that, it's because in the last course I took, and maybe I need to review more about this course, but we defined a function as some relation such that x relates to y and x relates to z implies that y equals z.
Okay.
That was like the formal definition of a function in that course. And that's why I was saying that this Cartesian product is not a function.
No, it's not a function. Exactly. It's not, for sure. So Patrick, let me
because one relates to A and one relates to B. Yeah.
So Patrick, there were two things you just spoke about. Let me clarify one by one. The first part you spoke about was about the definition for functional property. That's exactly right. So if a relation satisfies that functional property you just described, it would be the definition for a partial function. So what you learned in your earlier course, I guess, whenever you say it's a function, you really meant a partial function. That's the most general function you can say. That's a partial, right? In the case where the domain is exactly equal to the first set, we say that it's a special kind of function called total function. So that's a part one I want to address. And for part number two, for this Cartesian product over here, it's guaranteed always it's not a function, because you will definitely get, for example, how do I disprove it, right? So this is not a function. Okay, so this will violate the functional property. I'll say not a function. And if I want to give a witness to disprove it, for example, I can give, I got 1A and also 1B, right? You can see both 1A and 1B, they will be members in this particular function, in this relation over here. So that means it will violate the functional property. So this is not a function. So that means in this case, I can simply cross it out. Even though it's a relation, but it's not a function. So that's why I don't include it in my final set of the partial function. So Patrick, does it make sense to you?
Yeah, that's what I was thinking all along.
Awesome, very good. But you can always just find me for more clarification. That's fine. Yeah. So guys, don't think that once we move on to the more concrete case study in the later weeks, that these stuff are not relevant anymore. They're always relevant. You can always ask me for clarification for the functions relation kind of stuff, right? Let me do just one row with everybody, and then you can see what I've done so far. I simply try to enumerate all the possible relation in this set over here, and whenever I did one, I will cross it out if it's not a function, meaning that it violates the functional property. So this is one example, witness of violation. Let me do one more. And what about the relation of cardinality 1? Right? In that case, I got many possibilities, right? You can see the cardinality of this particular maximum relation is 6. Now I want to choose just one pair from one pair to make a standalone function, I got 6 different ways to choose. More precisely, I'll write it down for this one. I'll leave others to you. You can either be just 1a, or it can be just 1b. Okay, and also it could be just 2a, and also it could be 2b. Okay, let me move this a little bit downwards. Okay, over here. And also it could be 3a, and also it could be 3b. Right? Of course, the list can go on when we get to the cardinality too, which I'll leave to you. Okay, and now we got 6 different functions. You can see function number 1, function number 2, 3, 4, 5, and 6. Should we cross them out to be excluded from the partial function in this case? Well, the answer should be we shouldn't, because if you look at this function alone, there's only one single pair, and you cannot find any. Well, the only domain value you have is actually 1 over here. 1 is only mapped to A. It's not mapped to anything else as far as this function is concerned. So that's why it's a function. And the similar argument will apply to every other. So 1, 2, 3, 4, 5, 6. So these 6 should also be included. So far we got empty relation and also all these cardinality 1 relation. All of them, if you think about the diagram, not only that they are relation, but also they are actually here, right? Not only that they are relation, but also they are partial function, right? Right, and then you should really go on with the list about cardinality 2, 3, 4, 5, if you want to complete the exercise, right? Okay, guys, any more follow-up to this? So for the remaining part, I can simply say...
I have a question.
Yeah, go ahead.
So for in the area of cardinality 1,
yeah,
so all of those sets they're functional, right? Like
they are
functional is true.
Yeah. So okay, let's understand this. Okay, so if you look at this one specifically, you can see this is a member of the maximum relation. Is a member. So we simply choose one member from there, basically 1a, and we make it a cardinality 1 function. So notice the syntax here, that's really important. It is a set, and the set contains just a single order pair over here. So that means it's a relation of cardinality 1. And to decide whether or not this should also be a function at the same time, you want to make sure it satisfies the functional property. So the way to check it informally is to make sure every domain value you have over there is only mapped to a unique, only one range value. In this case, it is. So that's why it is a function. So this is a function, this is also a function, and etc. for all the other 5.
Oh, within that set, there's a, because okay, I see.
Yeah, I think
if like
yeah, go ahead.
Yes, I was saying like so like if in that set instead of just 1 there was a like 1a comma 1b, like so there were 2 ordered pairs in a set.
Yeah, indeed.
So that wouldn't be functional.
That wouldn't be a function. Yeah. So you're looking ahead a little bit. So I can write it out over here. You're basically talking about when we get to this particular category over here for cardinality 2.
Oh.
One of them would be, let me write it down. That might be for the benefits of your fellow students. For that one there, for example, I can write it down here. You're talking about 1a and also 1b. One of them, right? And in the lecture, we spoke about how many in total there would be for cardinality 2 relation. You can look up the lecture, right? And you're right, for this one here, it will not be a function anymore because the same domain value maps to different range values. So it violates the functional property. So that should be crossed out. That should not be included as the partial function. Does it make sense to you?
So what do you mean by it should not be included? For the partial function.
Yeah,
like,
because the
mm,
question itself is to enumerate the set of all possible partial functions between these two sets. So what I suggested
okay.
was we should start with the relation over here and then cross out anything that does not satisfy the functional property. So if effectively we'll get this set only. That's what I meant. Clear? Maybe?
Okay. Yeah.
Yeah. Okay, good. Think about it. You can feel free to drop by office hour either today or Monday. We can clarify further. Alrighty. Any follow up to this? Anybody? Okay, very good. Let's now move on. And this diagram will be so important. Please make sure you understand that. Oh, got some chat question from Patrick. Let me see. Just to make sure, as long as a relation satisfies the functional property, then we can conclude that the relation is a partial function. That's correct. That's correct. That's the very definition for partial function, right? Let's now just go back to just to double check, right? If you go back to your slides and then look at the partial function, you can see here we say that to be a member of the partial function, so that means number one, it should satisfy the functional property. Number two, the domain of the relation should just be a subset of S, right? So it can either be a proper subset or simply equal to S. In the case of the total function, we are only allowing the special case where the domain is exactly equal to the first set, right? That's a special case. That's why when we visualize the set, you will see the partial function is over here, and only those whose domain is actually equal to the first set will be considered as total function, right? They kind of correspond to the formal definition. All right. Any other follow up before I move on? Anybody? Okay. Very good. And I believe there's one more question from the Google Doc, and this one has been answered already, right? Is every function partial? Yes. As long as it satisfies the functional property, it would be a partial function. And of course, we got many other subsets within the partial function, which I just spoke about, right? You can refer to the diagram over here, which will be very helpful in terms of clarifying the categories over here. Alrighty, that's about everything I could see in the Google Doc. If you added the question maybe about less than 30 minutes before the session, I wouldn't have seen them. So I'm gonna pause right now for a moment. Do you guys got any additional questions related to lecture? I do want to highlight some certain things in your lab number 1, but of course you still got to go over the solution yourself and make sure you follow properly the video, right? And Patrick. Patrick, go ahead.
On E-class, there was one one specific question that was asking us to compute the power set of some I think it was some union and some set difference. And
okay, yeah. In the example question, yes.
The question I had, yeah, that I think you know the one I'm talking about, but
I know which
question,
one
I think is a little ambiguous. It's a little ambiguous in the wording.
Sure.
Because,
tell me
when we say the power set of.
If you tell me where it is ambiguous, I can improve the wording for your actual test. That's not a problem. If you can tell me exactly where.
It said a final set,
yeah,
right?
Give me a moment.
I have to pull it up.
No, that's okay. I can. You can see my screen, so I can pull it up.
Yeah.
No problem.
Yeah, so it was on the E-class quiz.
Yeah. I'm pretty sure. Let me see. Do you remember which question it was? Was it number 2? Sorry, my internet's slightly slow. Give me a moment. Let me let it load. Yeah.
Give me 1 second. It was question. Yeah, it was question 3.
Question 3. Thank you. This one here, right?
It was asking about the cardinality of some.
This one here, right? Is that the one?
It's still loading.
Still loading? I think, how about now? Is it, okay, you know what? Let me just copy and paste. Give me a moment.
On our end. Right.
Okay, it's on our end. And can you see that question
That's
here?
the one.
Good. Okay, that's the
Yeah.
one. Okay, that's better.
Yeah.
All right. So
I found it slightly ambiguous.
let me see over here. I can definitely try to improve that a little bit for sure. Yeah, I see what you mean. You want to know whether the power set will actually apply to the entire thing, or maybe it should just be a power set of something and then divided by this, right? Yeah, I see what you mean.
So the way I saw it was the open parentheses were dictating what we were computing. The parentheses were dictating what we were computing the power set of. So I did the power set of ABCD difference AE, and then I unioned the power set with AM.
I see what you mean. I see what you mean. Yeah.
So I was hoping that if on the test we can improve this and make it less
ambiguous. Absolutely. I might, to be honest with you, I might just say the cardinality of the power set of, and then I'll simply spell it out like that.
Yes.
There'll be no ambiguity.
Perfect.
Yeah, no problem. That's a reasonable request. I can do that. Yes.
Great. Thank you.
Yeah, no problem. All right. That's a valid concern. All right. Let me move back. And I got one question related to lab 1 here. In lab number 1, is the credit limits the same for all the accounts? Yes, that's more like a universal policy for the bank. Yes. So we don't really have like a account specific credit limits, which will make things more complicated, which we don't have to go to. Yeah. All right, guys, before I move on to walking you through very quickly about the solution for lab number 1, do you guys got any additional questions? Anything else? Anything? Okay. Hopefully everybody is still comfortable, right? Okay. All right. Let me now go over the solution. But of course, you can go to eClass and download the solution. I think I just want to walk you through about things that we declare and things that you want to think about. I think many explanations have been done already in the lab 1. I don't need to repeat them. So if you already watched them and get it, good for you. If you really got confusion, anything that's not clear, either you can ask me now, or maybe come to me during the office hour. All right. Okay, so question here, how is invariant 1 being discharged? You talk about invariant 1 over here being discharged. I'm not, I need a context. So which part of the tutorial are you talking about? Which events? For lab number 1, luckily, everything that we try to prove can be discharged automatically. But you should really know for some particular events what the proof obligation is about, right? That's something I also went over with you in the lab. So if you can make, if you can make a question a bit more elaborate, that will help.
Yeah, so from what I understood about Rodin, I think like the 3 post tactics that we defined, like as everything being discharged using those post tactics.
Yeah, post statics. Yeah. Mm-hmm.
Okay, so in the tutorial video, I think it was part E2, like towards the end of it, you say why phi is an element of Z, because the empty set, you can't give a counterexample. And so I understand it theoretically. Mm-hmm. So I guess I'm talking about invariant 1 and then act 1 and the proof obligation that came because of that.
Are we talking about the initialization events right now, since you talk about empty set?
Yeah,
okay, good.
Yeah, exactly.
And you're wondering about how this can be discharged, right? Invariant number 1.
How is like Rodin discharging it? Like theoretically I understand what's
it's a good question here. You can think about the very basic stuff, like how, for example, in this case, what in order to really discharge invariant number 1, what Rodin would do step number 1 is to replace the B over here by just empty set. So they will simply got empty set is a member of this partial function, accounts partial function, and this, right? And that will be basically step number 1 for the auto-prover of Rodin. And then basically until this step, I think there are many internal rules that the Rodin actually maintain. And one of them is simply say the empty set is really a special case where it will automatically be the partial function of anything. That's how it is discharged automatically.
Okay, that makes sense because yeah, like my question was, are there other rules that Rodin has?
Oh yeah, exactly.
In the set?
Yeah, you can think about this one here. We understood it also theoretically why it should be a partial function. So that's why Rodin will put it as one of the rules for when they want to discharge the theorems. Yes, correct. Good, very good. And
Okay,
Patrick, yeah, no problem. Patrick,
Isn't this statement here that you wrote, the empty set is an element of this partial function? Isn't that just a true statement?
it's a true statement.
So isn't that just what it is? It's the empty set isn't a partial function in itself. I mean, it is, but that's not the reason the statement's true, right?
No. Okay, let's get a flow. You are maybe confused about the flow. So think about a flow like this. We are trying to model our system as a machine. And if you when you go over the lecture week number 3, you will see that we talk about abstract state machine. But anyway, machine is simply like a computation where we simply got variables. We got D, we got B, we got D, we got owner, and then we specify their types in the invariant part over here. That's step number 1. That's what we're doing. And then we have to say, how can the system be initialized? So whenever we initialize a system, it's like initializing the attributes values in your Java constructor. It's a kind of analogous to that. And when you do that, you want to make sure you give some initial value for B. Empty set is just one possible value you can give to the partial function, right? And what Rodin would do is to check whether the initial value you specify over here is going to qualify to be a partial function. So that's why they will check to see whether or not this is a provable statement. And indeed, it is provable, trivially.
Wait, sorry. I think I'm confused maybe about invariant 1 itself. So is invariant 1 stating that B is a partial function, or is it saying that B is a member of this partial function?
Oh, okay. That's something you also may want to go back to week 2 lecture.
I think I need to review, yeah.
That's okay. That's okay. I can tell you that. Just give you some quick clarification. But I'm glad you asked. If you look at this over here, right? This expression alone is the set of possible partial functions between accounts and integer. So this is what it means. It's going to be a set of functions. And then the membership over here is saying that B is just one of the function. Just one of them. It's a function, not a member of the function.
Okay, yeah, sorry. It clicked in my head now. I was
okay.
The,
yeah, you rather it clicked before the test.
The syntax wrong.
Yeah, sure.
Yeah.
Yeah. Patrick, no worries. I mean, I'd rather you click, before the test, not after the test, right? All right. Okay, very good. Okay, guys, let me just go over, the construct here very quickly and just point to you what's really new in addition to your tutorial, right? So you can go over them and reach out to me, maybe office hour, or maybe either today or one day. Okay, let's go quickly. Okay. So we talk about in your lab. Let me highlight the thing that's new. Okay. What's really new? Number 1 is this person carrier set, right? So now we want to talk about the owner of each account. So that means we're going to have a person carrier set. And notice my comments over here. Whenever we actually make a carrier set, that's simply because the details for each member in that particular set, we simply don't know, or we don't have to specify. So what's really each member in the person? What's their name? What are the attributes of a person member? We don't need to specify. That's why it's simply just a carrier set, right? It's just a modeling convenience for us to be abstract at the moment. Okay, so that's one thing that's new. And also, I think we also got the L over here. It's more like an upper bounds for like account balance. Remember, we actually said that for each accounts, right? If we want to inquire about its balance, we say that it should be larger than or equal to the minus the credit limits, right? That's something we said in Lab 1 tutorial. We also want to make sure it's upper bounded by L, some preset limits. So that's exactly this L, right? Which is kind of symmetric. And of course, whenever you do withdraw, you want to make sure you don't really go below. You don't. Whenever you do withdraw, you don't go below the minus C credit limits. And symmetrically, whenever you do deposit, you want to make sure you don't really go above the larger limits, right? That makes sense. And here we say that the L that we introduce is actually a positive number, right? That makes sense. The upper limit we don't allow that to be 0. So these are the 3 things that were added in the solution. All right, that's number 1. Okay, let's now go on to the variable, the machine. So here, this is only about the context, right? That's pretty straightforward to actually see the new bits. And what about the machine? So this is new, owner, right? If you look at the requirements, environments requirements number 9, that talks about the owner, for the bank, right? That's new. And also you can see here, that's also the typing constraint for the owner. So what we're saying is owner is a member of the set of all possible partial functions between accounts and person. That means owner is a partial function, right? That's something you want to keep be careful. And there's a partial function, meaning that as long as you satisfy the functional property, you will be okay. So that means empty is okay to begin with. All right, and then we got another thing over here. So there's a property over here, invariance. So that will be the domain of the balance function, which we did in the Lab 1 tutorial, and also the domain of the owner function that we just introduced. They should be exactly the same. So we are talking about the same set of active accounts for both the owner and also the balance. Right, that's what we are. And I got some comments over here about why in Rodent you have to make this actually an axiom, or actually like an invariance, but not a theorem. Okay, you can see the explanation over here. We will try to revisit this maybe later when we go to lab number 2, right, or maybe some other lab. Okay, that's about the new bits about variables and also the corresponding invariance. Right. Oh, one more. Sorry, and also about the balance should be upper bounded by the large limits. Right. About L. So these 3 new things are actually new. Okay. And let me move on. If you got any question, please just feel free to interrupt. Okay. And we talk about the bank. Let's say talk about the different events. Okay. For the initialization, so now we got to make sure we initialize the owner over here just to be empty. And remember, it's a partial function between the account and the person. So empty set will be a safe choice, right? And then, by the way, so this part here we already spoke about, right? I'm just repeating that just so you can see things side by side. So that's about initialization. Let's take a look at, let's say withdraw. Withdraw is basically that something that we, let me see. Okay, so this is about exercise number 2 from your lab over here. Okay, so let's just go over the withdraw very quickly. Whenever you want to withdraw, you basically have to say which account you want to withdraw, and also how much you want to withdraw. And so these are the different guards that you want to make sure you have over here. If you took out any one of them, you're going to actually get undischarged proof obligation. Okay, I believe in lab number 1 tutorial we spoke about this one being important, right? Actually, that's the one I left as exercise for you. So this is there you go. You want to make sure the account, the value you're trying. Let me give you one example. Let's say, for example, let's say this is the current states. Okay, this is the current states where, let's say, the account balance, let's say it is 20, right? And then let's say the credit limits is actually let's say 20. That means you can go down to minus 20. That'll be safe, right? As long if you go to minus 21, so that'll be not good, right? So now if you try to say, I want to do a withdrawal, do a state transition, as if I want to withdraw, right? Let's say if I want to withdraw, let's say 41. In that case, it's going to create a state over here that is going to be account balance. It's going to be minus 21. In this case, minus 21 is not larger than or equal to minus 20. It is not. It's actually smaller than that. So that will be a violation for the invariance. Okay? And the invariance we're talking about is exactly over here. So that's something you would like to work out the logic over here. So that's why having this is so important to get it right. Okay? So that's relevant to invariance number 3. Okay, any questions so far that you want to talk about? Anybody? And a quick reminder, just about what we said in the Lab 1 tutorial. This part over here is more like a syntactic shorthand for, I basically want to modify b being a partial function, but specifically, I want to change the mapping for a from the original value to be ba minus v, right? You're going to subtract the amount. So this will be equivalent to, I can simply say b over here is assigned to, let's say b, the original function, and then I can do overridden, right? Remember, this is an overridden symbol. And then it's going to be just another relation, like a set of pairs. What I want to do specifically is I want to say ba, sorry, I want to really, so it's account A I want to change. So ba, and then in Rodin, you're going to say maps to. That's something you will see in other part of the solution. And then it's going to map to ba minus v. So this will be the alternative way for you to think. You basically want to update the relation, but specifically you want to update this particular mapping. But syntactically, you can also write in this way. That's something we also cover in the Lab 1 tutorial. I just want to reiterate to make sure. All right, any questions so far? Is it good? All right, so now if we go, go ahead. Yes, go ahead.
Could we have done this using like intersections and set difference as well? Like,
yes, you may. Yes, you may. I think as long as it's a valid answer in the test, if I didn't really constrain, if I say you can only use the overridden operator, you have no choice. If I didn't say that, sure. I think a set difference can also work if you want to.
Okay.
I believe you can do that, Patrick. I think you can simply say B is assigned to, I believe, you can try it out in Rodin as well. That would be the set difference symbol, I believe. And then I want to make sure I keep the B, everything there, but not in here. So that'll be the same, yeah. Yes, that'll be okay too. That'll be fine too, yes. All right, any other question before I move on? I got about 2 or 3 more pages to show quickly. Okay. All right, let me move on. And about the deposit, it's going to be very similar. I think this entire event is the solution to your exercise number 3. All right. What I want to draw your attention to is about this particular guard over here, right? You can see. I want to say that whatever value you want to deposit into account A, you want to make sure after adding the value V into the current balance of A, that should be less than or equal to L. So that one is really corresponding to invariant number 4. That's really addressing it, right? Over here, right? That's something I want you to make sure you understand, right? Other than that, I think the operation we did here is kind of symmetric to what you had to do for the withdrawal. All right. All right. Hopefully everybody's okay. All right. Let me do another one over here, which is about the transfer, right? That's one of the exercises. So that will be corresponding to requirements number 11. Okay. So the entire events is new. Basically, you can think about transfer is like a combination of withdraw and deposit. So that's something I'll leave to you to really make sure, right? Think about the transfer is like a combination of, we want to withdraw, first of all. We want to withdraw from A1 certain amounts, V, right? A1 and V. And then we're going to do deposit into A2, the same amount, V. You can think about these two things should really make up the specification for transfer. That's something we have to do. One thing I want to mention to you, you can definitely try it out in Rodent so you will see the error, okay? You might be thinking that you want to write something as the action over here. You might be thinking, I can say B of A1. That's what I want to withdraw from. It's assigned to maybe B of A1. I want to withdraw, so that should be minus V. And then the second action will be B of A2. That's what I want to deposit into, right? It's assigned to B of A2 plus V. However, Rodent wouldn't allow this syntactically. That's why I put the comments over here, right? Because for the actions, they are more like a specification rather than sequential execution of your assignments, like in Java. So they don't allow the same variable to appear on the left-hand side of this colon equal to operator, which I explained in detail in week number 3 lecture. All right? Right, so over here, you cannot really have just the same variable over here. You cannot. What you got to do instead is to say B is overridden by, right? That's overridden symbol. You got to say A1 and also A2 separately. Right, so that's something I want to draw your attention to. Pay more attention to this. All right. All right, any questions so far? All right, final slide, final page, which is about how you can open the account and also how you can close the account. It correspond to requirement number 4 and requirement number 10, right? So these two, all right? I'll let you study the guards and also actions over there, but you can definitely see we got some guards, we got some action here. So guard and also action there, right? I'll let you study them, right? So these are quite straightforward to actually get right. Okay. Okay, we got actually we should have finished the session 10 minutes before the hour. But if you guys got more questions, I'm more than happy to answer. Any follow up to example test questions, lab 1, lecture week number 2? Anybody? Anyone? Yeah, make sure you refer to the preparation guide for your written test 1. Make sure you don't really miss any items to study for the test. All right, and do the example test to make sure you know the formats. And then you still got a chance to ask me questions either today or Monday. And on Tuesday, I will see you virtually to see the to do the test. Right, 2 p.m. office hour, 2 to 3 p.m. Monday, Tuesday, Thursday. All right, I got a thumbs up. Thank you. Okay. Is there a video for lab 1 solution? I'm afraid no. I wish I had the time. I'll be very happy if I got enough time to do it. So that's it. I think I try to walk you through of all the things you should really pay attention to. So given that you already studied lab 1, the basic, and then so all the extensions that the solution require already highlighted to them, highlighted them for you. So if you got any question about the solution, reach out to me. Right. Sounds good.
Thank you, Jeff.
Guys, no problem. My pleasure. I think please make sure you study over the weekend. Well, take some rest as well. I'm pretty sure you're pretty busy with other courses. But if you got any questions about the stuff, reach out to me and I'll try to respond. Alrighty, I'll let you go now. Guys, take care. Have a good day. I will see you next week.